All right, today I just want to do a few examples. I'm reminding you what the general equation is for a sinusoidal function. A is the amplitude, B tells you the period, C is horizontal shift, D is the vertical shift. Also, Y equals D is the midline. Okay, so here we go. I got a sine graph. It's got a max at 2, 5, and then following max at 7, 5. So those are coordinate pairs, x, y values. The midline's y equals 1. So we're going to determine a few things. First is going to be the amplitude. I'm just reminding you that the amplitude is the maximum displacement from the midline. We know the midline's y equals -1. So if I just sketch something here, this is -1. There's a maximum up at 5. Okay, the displacement from the midline to get up to the maximum, here to here, that's 6, right? To get from -1 to 5. So the amplitude's 6. It also means that this graph is going to go 6 down from the midline. So it'll look something like this. Okay, that'll help us answer part C. Okay, next we're going to find the period. So I mentioned you can find period from this number b, but we don't know what that is. The other thing you can remember about period is that it's the distance between the maximum values or the distance between minimum values. We have two maximums, 2,5 and 7,5. Okay, the distance between them from 2 to 7 is 5. That's the period. All right, next we got to find the minimum. So we know the amplitude is 6 and the midline's at -1. So it goes 6 down from -1. So we just got to do -1 minus 6. The minimum is going to be at -7. Okay, so the graph goes from -7 up to 5. Halfway between there is -1. That was the midline. Okay, 6 up is 5. 6 down is -7. Okay, let's do another example here. This is a good one. We're going to need our calculators here. So it's the height of a person on a Ferris wheel. Nice little equation there. You want to be in radians. Okay, so there I am. You can tell you want to be in radians because otherwise this would be in degrees. The horizontal shift would have to be in degrees. All right, I'm just going to inspect this formula a little bit. I know that the maximum is d plus a. Okay, so that's going to be 43. The minimum is d minus a. That's going to tell me what to do with my window. So x is the time. I'm going to go from 0 to, say, I don't know, 10 minutes. The scale doesn't much matter. So min, I'm going to take 0, and I'm going to go up to, say, 50. I know the maximum is 43. As long as it's more than 43, I think you'll be fine. Okay, I think this will make our graph look nice. So now I'm going to input it, 21 sine 3x minus 1 plus 22. All right, let's see what we get. So there's the Ferris wheel going up and down. Maybe you don't stay on for 10 minutes, or maybe this is a fast Ferris wheel. I don't know, I just made up the numbers. Okay, so determine the height after 1 minute. The height is a y value, so we just need to trace 1 here. I get 41.1. All right, part B, the radius of the wheel. Well, we'll have to think about that. So I want you to picture a Ferris wheel. Okay? So you get on, it goes all the way up, all the way down. Halfway, be like that. This is like your maximum height. This is your minimum height. So the radius of the wheel, I think you'll agree, will be the amplitude of the ride. Okay, so if you start here, you go up and then down, okay, and then around. Your height would look like this. You go up to the top, then you come down all the way to the bottom, and then you're going up again. Okay, the amplitude is the radius of the wheel. I'm trying to convince you of that. So the radius of the wheel, 21. Okay, meters. Period. Remember, period's 2 pi divided by b. B here was 3. Right there. So that's going to be in minutes. I'm going to actually calculate that, because if I say meet you in 2 pi over 3 minutes, you have no idea what I'm talking about. So this is 2.09 minutes. Okay. Last one. When the time equals 30 meters. All right. I'm going to limit our graph to just one period. Okay, I don't want to be looking at all of this. So I know the period's 2.09 minutes. Maybe I'll just go up to x max of 2.5. See what it looks like. Okay. So this is going to be an intersect. We're going to make y2 equals 30 and do an intersect. And I think there's going to be 2 answers. Do not write over your formula. Okay, there we go. So you hit 30 meters on the way up, and you hit 30 meters on the way down. We're going to find out when those times are. This first one will be on the way down. It's going to be 1.25 minutes. Okay, for the other one, I got to move my cursor closer to the other intersection. And I get 0.46 minutes. Those are my answers. Okay, I'm definitely going to give you a Ferris wheel question. They're just easy. Maybe the only thing that doesn't quite make sense, I tried to convince you over here, the radius of the Ferris wheel will be the amplitude every single time. So if you remember that, you'll be in good shape. All right, I got one more short example for us where we're just going to look at a graph that I sketched quickly here. We're going to find the period and range of this sine graph. Okay, so I tried to make it look nice. I think it looks okay. I remember period is the distance between maximum values. Okay. Oh, I've got that listed, -1 to 3. We're done. Okay. So the period equals 4. I don't think I've asked you about range before. That's just y between the minimum and the maximum values. Okay. So let's look at the minimum value is -1. I've labeled it here. The maximum value is 4. I've labeled that here before. Just a coincidence the period is 4. So these values are y equals 4. So the range is from -1 to 4. That's how you could write that. All right, so that's a simple example.